This question says, a chemist carefully measures the amount of heat needed to raise the temperature of a 550 milligram sample of a pure substance from minus 2.2 degrees C to 8.7 degrees C. The experiment shows that 2.69 joules of heat are needed. And then it asks, what's the specific heat capacity of the substance? So specific heat capacities are essentially a material's intrinsic ability to absorb heat. So if we look at the specific heat capacity for water, for example, it's equal to 4.18 joules per gram degrees C. And the specific heat capacity of iron, for example, is equal to 0.444 joules per gram degrees C. What this means is that when the same amount of energy is applied to water and to iron, water will raise its temperature 1/10 as much as iron because it can absorb approximately 10 times more heat. This is 4, this is 0.4, approximately 10 times more heat for a 1 degree Celsius change as compared to iron. These are experimental values and they're intrinsic to different materials. In this case, I give you water and iron. Now, the mathematical equation that can describe specific heat capacity, or at least that contains specific heat capacity, is Q, which is heat, equals M, which is mass, times specific heat capacity, C sub S. I'm just going to write it as specific heat, times delta T, which is change in temp, your change in temperature. So Q is generally in units of joules. Heat is in joules. Mass is typically in grams. Specific heat is usually in joules per gram degrees C. And then finally, change in temperature can be in degrees C or Kelvin, because a 1 degree Celsius temperature change and a 1 K temperature change are the exact same change. Think about it this way. If you have something that warms from 0 degrees C to 1 degree C, delta T equals 1 degree C. However, if we convert both of these temperatures to Kelvin, 0 is 273 K and 1 is 274 K, because I added 273 to each. I left out the 0.5, so I didn't add 273.15, but just 273. So anyway, 0 degrees C is 273 K, 1 degree C is 274 K. The change in temperature here equals 1 K. Said another way, the magnitude of change, 1 degree C and 1 K, are exactly the same. So your temperature change can be in C or K. Here, in this question though, we're actually asked to solve for specific heat capacity. So we have to rearrange this equation. And to do that, we divide by M and we divide by delta T. And what we get is C sub S equals Q over M times delta T. So this is our new equation. In order to solve this equation, we need to plug in the values. The first thing I notice is I don't know delta T, so I need to find delta T. Well, delta T equals TF, the final temperature, minus TI, the initial temperature. So in this case, it's 8.7 degrees C minus negative 2.2 degrees C. Since we're subtracting a negative, we add, and we get 10.9 degrees C with 1 decimal place. So we now have delta T. So now we can plug in Q, already in joules, so go ahead and plug it in, 2.69 joules. M is in milligrams, and we want it to be in grams because that's a more typical unit, so we divide this by 1,000. So instead of 550, it's 0.5500 grams, which is just simply this divided by 1,000, or multiplied by 1 gram per 1,000 milligrams, times delta T, which we just found. Delta T we just found, which is 10.9 degrees C. Now, just simply do the math, and the calculator gives us the C sub S of 0.448 707, and some more numbers. However, because this is 3 sig figs, this is 4, this is 3, this should be 3 significant figures, so the best answer is probably 0.449, and the units are joules per gram degree C. Per gram degree C. So this is our specific heat capacity for this question.